Hello everybody and welcome to the bonus lesson for the Roll-a-Ball tutorial for Blender game engine. And in this bonus lesson we just quickly write another function in our script that will change the movement with some gradient, with slowly acceleration and stopping down. So right now we just create some vector and set the velocity to that vector without any smooth change. It's just you hit the K on the keyboard and the velocity is changed. So we put one line here between the pure vector and the changing, and we will change this vector a little bit. We will change it movement vector, and it will be equal to some other vector that will be computed from this, and this will be done by with linear interpolation. So it will be lerp function, and we will put there the start velocity, which is the current one. So the current velocity is player get linear velocity, I believe, yes, and in global axis, so false. So this is our current speed of the ball of the player, and our desired speed, the speed we want, the direction, the vector we want to move, is our movement vector. So we have some starting vector. It can be 0, it can be whatever, some vector that we want to achieve, but we will not jump just from one to another in one frame. We will slowly change this vector from the current speed to the movement vector with some speed, for example 0.3, and not larp but lerp, and this lerp function doesn't exist, as you can expect, so we will define it. It shouldn't be that hard. Just define our function. So instead of this we want some start vector. It will be our start, some target, and this is, as I said, speed. And we will do something with it. First of all, we set the new vector to something like new position. For example, it should be more understandable what it does. So the vector can be positioned in 3D space. So we have position start, we have position target, and we just calculate the new position somewhere between these according to speed of the change. So the new position is none in beginning, it's nothing, and we need to know the difference between the target and start. So we just calculate it like difference equals target minus start, and this is our difference vector from start to target. If you don't know this vector math, just go to Wiki and Wikipedia, Google, whatever, YouTube, and you will find out that if you subtract the beginning from the end, you will get the vector exactly from start to target. It it makes sense after a while. And we will look at this difference and look at how big it is. And we already know how to measure length of the vector in Blender. So if this difference magnitude, and because we are still writing our functions in the one script, and in the beginning of the script is BGE and matutils import, so we don't need to import it again. We can just use all these functions like magnitude. And if this magnitude is lower or smaller or equal to our speed value, we don't move according to anything. We just set our new position directly to the target. So if we are very close, we don't need to calculate any other motion. We just put it right there, right to the target, and it will end right here. And else, what if the difference is bigger than the speed? So the points in space are further away. We want just to move the new position according to speed, so just the speed length and the direction to from start to target. Well, we should calculate the direction, but if you are familiar with vector math, direction of the vector is actually end minus start. So the difference vector is actually our direction. We already have it. So we don't need to calculate it again. We just set this direction exactly to our desired length. So we take this difference, which in this case is also a direction, and set its magnitude and set it with equal exactly to speed. So now we have precisely the vector we want to move our new position from start. From start we will move about this exact vector, the difference, which magnitude is from now on the speed. And we want to change our new position, so the new position will be, we are moving from start, so it's start plus our difference. And it's all again, it's everything. We will just return back our new position. And it's all for S, start it, and control no errors. Let's move around a little bit. Not here, here, no errors. And you can see that the ball actually accelerates. I am sorry for the resynchronization, but the screen recorder isn't really friendly for these things. And I am using WSAD, I am using arrow keys. Everything works as it should. So, thank you for watching, and till the next time, bye.